Okay, so here we go. Put it over here. Okay, so remember, from the unit circle, we could plot a point x comma y, but what if the radius isn't 1? So watch what we can do. We can actually drop the perpendicular. This is to the right x, up y, but the radius we'll call r. And in the right triangle, we can actually define the 6 trig functions using this. So from SOHCAHTOA, sine theta would be y over r. Cosine theta is x over r. Tangent theta is y over x, and I'm just getting it from my little triangle here. Cotangent is the reciprocal of tangent. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. I need to tell you, I don't use these. I don't use these at all. I don't memorize them. I just draw my triangle every time, because to me that is easier than trying to memorize 6 more things. I think our heads are about to explode with all the information we have in there. So if you like that sort of thing, you can use this. This is the way the textbook explains it. But then in example 1, I'm going to show you what I like to call the triangle technique. But the note here is, since r is the length of the radius, that can't be 0, because then you wouldn't have a point out on a circle. It follows that sine and cosine functions are defined for any real value of theta. However, if x is 0, look at tangent and secant. If x is 0, it's undefined, and we're going to actually determine there's vertical asymptotes there. Now, they don't mention it, but if y is 0, we also have a problem with cosecant theta and cotangent theta. But we'll get to that when we do our graphs. All right, so let's plot -3, 4. It's a point here, and it says let -3, 4 be a point on the terminal side of theta. Okay, so that means here's theta, and we're going to use, before I formally define, reference angles here. If I drop a perpendicular, I've moved left 3. Even though the length of the triangle can't be negative, I'm going to go ahead and put the sign there, because it's going to help me with my all students take calculus. It's up 4, and then this is a 3, 4, 5 right triangle. And if you can remember from your trigonometry from Algebra 2, this angle here is called theta prime. I will be defining it in a moment, but for now, if you just remember, that was theta prime. I can actually use, as long as I do all students take calculus, I can use the reference angle to still determine the trig values. So if I want the sine of theta from SOHCAHTOA, it's 4 over 5, and it's positive, right? Because sine is in the second quadrant, it's positive there. It says find cosine theta. Well, the reason why I put the -3 there is because then that'll take care of that cosine's negative. And then the third one they've asked us for is tangent theta. It's 4 over -3, but remember, in a fraction we always keep the negative in the numerator. Okay. All right, let's do another one and see if this is starting to gel. If I want to plot 4, -3, this is in the 4th quadrant. Now that's the terminal side of angle theta. But what's going to happen is I can use theta prime as the reference angles, because it's going to produce the same trig values there. So I went to the right 4 and down 3. So again, it's a 3, 4, 5 right triangle. And if I use that 3 is negative, I'm going to be able to do this correctly. SOHCAHTOA, it's -3/5 for sine. And that makes sense, because in the 4th quadrant, sine is negative.
Mrs. Smith?
This is Mrs. McInerney.
Oh, sorry. Thank you.
Okay. and that makes sense. And then TOA is negative 3 over 4, and that makes sense because tangent's negative there. Okay? All right, and then something I just love about pre-calculus and trigonometry is that it's not so black and white in terms of, oh, you just do this. It's a lot of analyzing and thinking things through. So when we do example 3, it says I'm given tangent theta is negative 5 fourths. So let's pause here a moment. I'm going to cover up the rest of this. And if tangent is negative, what do we know?
Second or fourth quadrant.
Good job. If tangent is negative, it's either second or fourth quadrant. Well, if that's all they told me, I wouldn't know what to do. But then they gave us this other piece that said, okay, well, cosine theta is positive. Now, out of the second and fourth quadrant, which quadrant is it in?
First and fourth.
Fourth. I mean, we were only looking at the second and the fourth. Yeah, you're right, cosine is positive in the first and the fourth. But if we're using the beginning piece, that I'm either in the second or the fourth, and then cosine has to be positive, I've now eliminated it down to the fourth quadrant. So I'm in the fourth quadrant, so I'm going to do the triangle thing. If I call this theta, here it would be opposite over adjacent, but one of the two numbers is negative. And I have enough information to figure out which of the two numbers is negative. Is the 5 or the 4 the negative?
5.
5. Why? Why, Haley? You're right.
Because it's going down.
Going down. It really is that simple. The y is going down, the x is going right. Now, this is not a 3, 4, 5 right triangle because the hypotenuse has to be the longest side. So you're going to have to do Pythagorean theorem. 4 squared plus 5 squared. Okay, 16 and 25 is 41. And I take the square root. Now, the hypotenuse will always be positive. Okay? So now, if I want to find the sine of theta, it's opposite over the hypotenuse. And I think we're getting really good at rationalizing now. That's negative 5 radical 41 over 41. And if you can do it without showing the work, that is terrific. All right, secant theta. Secant is the reciprocal of which trig function? Cosine. All right, well, cosine, SOHCA TOA, is adjacent over hypotenuse. So this is hypotenuse over adjacent. So it's radical 41 over 4. All right, any questions up to this point? Anything at all? All right, example 4 then says, evaluate the sine function at the 4 quadrant angle. So I want to find the sine of 0, the sine of pi over 2, the sine of pi, and the sine of 3 pi over 2. Any ideas?
Unit circle.
Unit circle, beautiful. So here we go, we're going to draw our circle. And, okay, one other thing we need from our unit circle is the sine value the x coordinate or the y coordinate? It's the y coordinate. A helpful suggestion, I mean this isn't very mathematical at all, but if you're having trouble remembering which one's sine and cosine, C comes before S, so the cosine comes first. A little goofy, but it works. So according to that, in our unit circle, what's the sine of 0? 0. What's the sine of pi over 2? 1. The sine of pi? 0. And the sine of 3 pi over 2? Negative 1. Okay, so you just read it right off the circle. All right, if theta is in standard position, then the reference angle theta prime, and remember that's how we say it, it's theta prime, associated with theta is the acute angle formed by the terminal side of theta in the x-axis. So we did this last year, so hopefully this will be a little bit clearer. Here's the deal. if you want to find a reference angle, you're going to draw your angle, and the reference angle is how far does the terminal side have to go to hit the x-axis. So how many degrees away am I from the x-axis? 60 degrees. Now, in letter B, is 2.3 degrees or radians?
Radians.
It's radians, because there is clearly no degree symbol. Alright, well, suppose we don't have a calculator, and I'm trying to figure out where is 2.3. Well, I know this is 0, and I know pi is 3.14. I need to get some kind of idea as to what is pi over 2, and suppose we don't have a calculator. So I'm just going to take pi 3.14 divided by 2. And it's not like you have to know it exactly, but it's about, 1.57. So 2.3 is in what quadrant? The second quadrant. So here's my 2.3. So to figure out theta prime, we're going to take pi minus 2.3. I did use my calculator. And I got 0.8. I admit it. I then used my calculator, and I got 0.84. All right, letter C, theta is negative 135 degrees. Okay, this is a negative rotation, and you guys should really become familiar with your 45, 135, 225, 315. Those are your 4 45-degree reference angles across the circle. Just going negative 135 is moving you into the third quadrant. So theta prime, I'm just 45 degrees away. Reference angles are positive. They're between 0 and 90. You won't ever have a negative reference angle. All right, then the last one, 125 degrees. So theta prime is how far away am I from the x-axis. In the second quadrant, you need to take 180 minus 125, and what does that give you? 55 degrees, okay? All right, so now that we're armed with reference angles, we can actually evaluate any trigonometric function. So what you're going to do is you want to draw the angle, figure out what quadrant you're in, determine your reference angle, find the trig function at that reference angle, then do all students take calculus to figure out if it's positive or negative. I need to look at my next quiz, but I'd like to see all 4 parts. Like if it's a 4-point problem, even though I didn't come out and say draw where it is, I'd like to see evidence you know what quadrant it's in. So here, let me go through the steps. If I want to evaluate the sine of 210 degrees, well, let's draw 210 degrees. That identifies the quadrant. What's the reference angle then? How far away from the x-axis am I? Right? Now, we want to do the sine of 30 degrees. I would suggest you draw your 30-60 right triangle and your 45-45 right triangle and just have them ready for action. So the sine of 30 is 1/2, and then the sine of 210, all students take calculus. Only the tangent's positive there. So the sine of 210 is negative 1/2. So let me repeat the steps again. You want to draw the angle, determine the reference angle, do the trig function at the reference angle, then do all students take calculus to figure out if it's positive or negative. But we are technically finding the sine of 210. All right, now I need to share a little secret with you about radians. Students end up liking radians better than degrees once they figure this out. Did you know that the reference angle, when it's in radians, is the pi over? So this reference angle is pi over 4. That reference angle is pi over 3, pi over 4. If I gave you 13 pi over 6, the reference angle is pi over 6. Super easy, okay? I still need to know where it is. So negative 5 pi over 4, that's actually going to be in the middle of the second quadrant. And here's what I'm thinking. Negative pi is negative 4 pi over 4. When you have fractions, think of common denominators. Let me say it again. Negative pi would be negative 4 pi over 4. So negative 5 pi over 4 is one more pi over 4 into the second quadrant. So theta prime is pi over 4. Cosine pi over 4. Let me draw that triangle. This is 1, 1, radical 2. You really just ought to get to a point where if you say, what's cosine pi over 4, you should know it's radical 2 over 2. Sine pi over 4 is radical 2 over 2. Tangent pi over 4 is 1, because it's itself. Now that I'm in the second quadrant, is cosine positive or negative there? It's negative, so this is negative radical 2 over 2. But do you see my 4 steps? The picture, the reference angle, cosine of the reference angle, and then I am actually writing the cosine of the original angle and what it is. All right, tangent, pi over 3. All right, 5 pi over 3 is in what quadrant? It's in the 4th quadrant. And you guys, again, if you're struggling with this, an idea would be think about common denominators. If it's over 3, pi is 3 pi over 3. Okay, well, it's definitely 4 pi over 3 and then 5 pi over 3. Or you can think of, all right, well, is it close to 2 pi? 2 pi would be 6 pi over 3. So this is 1 pi over 3 away from a full rotation. Okay, so theta prime, I told you, would be just pi over 3. Tangent pi over 3 is tangent 60, so that's radical 3. And so tangent 5 pi over 3, all students take calculus. In the 4th quadrant, cosine's positive, so tangent would be negative. Okay? All right, cosecant, 11 pi over 4. Let's draw a picture. All right, 11 pi over 4. That looks like it's going to be more than once around the circle. It is. 2 pi is 8 pi over 4. So 3 pi over 4 is in the 1st quadrant, but we just happen to have where it went around 1 full time plus 3 pi over 4. So I'm in the 2nd quadrant. What's the reference angle? Pi over 4. All right, cosecant, pi over 4. Let's pause a moment. And cosecant is the reciprocal of what trig function? Sine. Okay, sine of 45 is 1 over radical 2, but I need the reciprocal. So it's radical 2 over 1, or radical 2. In the 2nd quadrant, sine is positive, so cosecant is positive. All right, any questions? We're going to practice a lot of these, okay? And get it down. All right, example 7 says, let theta be an angle in the 3rd quadrant so that cosine theta equals negative 1/4. All right, so let's draw an angle that's in the 3rd quadrant, but I'm going to drop a perpendicular. If cosine is negative 1/4, you know that's adjacent over hypotenuse, and one of those two has to be negative. Well, you're moving left, so the 1 is the negative. Now let's do Pythagorean theorem to figure out the missing side. So you take negative 1 squared, remember that's positive 1, plus, I don't know, x squared equals 4 squared. Aren't you going to get square root 15? And it's actually negative because I'm going down. So now the sine of theta is negative radical 15 over 4. And I'm done. Like I did all the hard work in my triangle. Tangent theta, TOA, is negative radical 15 over negative 1. And that's positive radical 15. And doesn't that make sense? All students take tangent's positive, but sine is negative. Okay? Alright, let's use this same strategy in example 8. It says let theta be an angle in the second quadrant so that sine theta is 1/3. Okay, so I'm drawing my angle in the second quadrant, but I'm going to drop the perpendicular over here. Sine is opposite over hypotenuse, and we need to find the missing side. So isn't that square root 8? But we would never leave square root 8. We're going to simplify it. And then since I'm moving left, it's a negative. So cosine theta, so TOA would be negative 2 radical 2 over 3. And in B, tangent theta is 1 over negative 2 radical 2. And I'm not actually using trig identities, okay, I'm just doing the triangle. I think this is easier. So then we're going to multiply by radical 2 over radical 2. And I'll bring the negative up to the top. And that's negative radical 2 over 4. Alright, then take out your calculators. And check your mode, and I want you to do the last two. And then I'll put my answers up in a moment.
Thank you.
Remember to get cotangent. You take 1 divided by tangent 410 degrees, and I got 0.8391. The second one, you'd want to change to radians and put the sign of negative 7. I got negative 0.6570. Anybody having any trouble with that?